In addition to the environmental conditions we've just looked at, there are additional characteristics of the work that might also, again, sort of point to what types of features might be useful at reducing error rates. And the first would be looking at, in essence, workload, and in particular, the sort of tempo or time pressure. So this is in part just sort of showing how difficult it is. So how quickly work must be created, in essence, the time that you have to spot the anomaly and respond to it. It's in some ways very similar to the idea of a dynamic environment, but the difference is it's not just about, it's more about the personal or demands on personnel associated with tempo and time pressure and the sort of barriers to communication that come from the nature of the work itself, as opposed to the fact that you need communication, for example, when you're facing a dynamic external environment. So again, the idea is here is that this is sort of cognitive and physical limits to some extent on either individual responses or sort of coordination throughout the organization. And in general, what you need as tempo goes up is sort of more automatic in the sense of actual automatic thinking. So it needs to be as practiced as, you know, tying your shoe or something, right? It needs to be something you don't think about, but you can just sort of do. So the types of features that can decrease an error rate under these sort of high tempo conditions will typically be lots of practicing and simulation training. So again, something you do repeatedly until you get quite good at it. The more that the frontline employees can actually focus on a few critical tasks instead of having to manage a lot. So again, think very much machine bureaucracy, right? You need to prioritize, specialize, and you need to have physical spaces that are conducive. So places that are not well organized, say if you're running around, you're trying to serve your coffee at Starbucks and you can't find the cups, that's going to really sort of, especially under high tempo situations, it's not a problem if there aren't a lot of customers in line, but if you have a lot of customers in line, it's going to really create stress and make you more likely to make a mistake, do other things that you might not otherwise do. And another feature that can actually help decrease or sort of offset this is authority migration to experts. So again, the idea here is that when you're having to make decisions fast, you sometimes don't have time for the decision-making authority to go all the way up the chain of command, all the way up the chain of command to somebody who doesn't have, who would take more time to make a decision. You often want the person who knows the most about it right at that moment, which often means a frontline person, but could sometimes be like an overseer. But you want that sort of expert to have authority migrated to them. So what do we see then is that in the ICS, especially strategic decisions are being made under pressure. We see again, as I mentioned before, in the case of the complex environment, you're again seeing this authority migration to experts. So in part, you're seeing the actual, and also you're seeing basically lightening cognitive loads via structural elaboration. So both of these are in some ways related to the idea that, again, you can elaborate out structure and you can also switch who's commanding the ICS. But there is another aspect of authority migration. In this case, there are some calls that get made by basically front level personnel, or at least lower level managers. So, but not necessarily the lead commander. So if they sort of have an isolated hazardous materials incident in the middle of a larger fire, you might not switch the entire command of the fire over, but you might just have the hazmat person be making decisions that need to be made in the ordering, say, of what priorities are relative to the hazmat, but maybe not relative to the overall fire, if they don't have as much experience out there. So that would be an example of, it's not just the overall lead commander changes, but the specific decisions get migrated down to lower levels. With the naval air case, we see both work tempo and actual physical congestion. So both of these, again, are stressors that are going to affect basically increase under high tempo, whenever the decks get congested, which is all the time, you're going to tend to have more mistakes and anomalies. So again, we tend to see organizational elaboration and specialization to deal with work tempo. This is specifically referenced. You tend to see authority migration. So in essence, the sort of generals and the colonels sort of step back and they let the low-level people make calls about where the airplanes are going, et cetera. And so it's one of the few cases in the military, as pointed out in the cases, where you can actually see a higher level officer reprimanded by a lower level officer for getting in the way because they're not following the rules. And it's expected that basically the experts who know where the planes need to be and where the fault lines are, etc., get to tell other people what to do, because the mission becomes more important than the normal everyday hierarchy under high tempo operations. Also, to, in essence, sort of ensure oversight, understanding how cognitively demanding it is, and the idea that under cognitively demanding conditions, even a single individual can make mistakes, is you typically try to have 2 or more pairs of eyes on every decision that's being made. In essence, it's a robustness feature. And robustness becomes more and more important under high tempo. It's not as necessarily as important under low tempo, where you have more time to notice that you've made a mistake personally and go back and correct it. To deal with congestion of decks, there's a lot of background work being done to prepare and organizing space during the low tempo operations. So again, this just gives you some sense of what the features are, what the sort of the way in which these things affect error rate, and then also the types of features and the mechanisms by which they work to address the error rate. Finally, the last set of features we're going to look at are those associated with basically barriers to authority and coordination. So in essence, whether or not detection and response to these anomalies require some degree of coordination and communication across lines of specialization, and again, keeping in mind tempo in a more or less sort of high tempo way. And also, so in essence, you need to have some ability, right, to recognize that there's an issue in one place and then coordinate it over to another place. Communicate it to another place. And then with, there's also the issue of basically who's responsible. So if something goes wrong, if it's nobody's, if it's everybody's job, it's nobody's job. And so this is another idea of gray space. And in some cases, you can also find gray space under uncertainty. It basically means when it's no one's job, again, it's everyone's job, because it's not an anomaly that anyone's used to dealing with. And if there's not a single ultimate commander, this is when unity command becomes sort of important. So what types of features can decrease the error rate given these barriers? Clear lines of authority and responsibility can often eliminate gray space, except again under environmental uncertainty that can end up backfiring. Usually though, if you've got pretty stable and certain environments, having very clear lines of authority and responsibility can avoid problems. There are also some features that can enable cross-functional or multi-level communication, like shared mental models, a dedicated communication expert, or other norms of teamwork or communication. You can also have sort of more formal processes of communication. It can definitely get harder, though, in some of these more temporary organizations. So what types of features can help meet the requirements then that we need to deal with to get rid of these barriers or address these barriers to coordination and authority? So for example, with the involvement of multiple organizations, obviously this flexible organization structure, the ICS itself, is part of what basically eliminates the gray areas, because you do have a single unity of command with an ultimate responsibility. And in addition, you have norms of communication back up, right? This constant idea of constant monitoring and easy authority migration that can really help it from becoming a formal organization that ignores problems. Interestingly, part of what happens is that there's extensive training, not in how to, for example, fight fires, but in addition, how you actually work within this ICS structure and function, so that everyone understands what the point of the ICS is. So again, this is a way of inculcating these norms of how you work in an ICS in a high tempo, dynamic, somewhat uncertain environment, which is what's being faced, a moderate complexity, in essence, environment. The other thing that you tend to see here is that you've got tight coupling of emergency activity. What that means is that you might have these different operational groups that are sort of divided up by function, like hazardous materials and firefighting and rescue and retrieval. But it turns out that you can't do one before the other. Like there's a certain order they have to go in order to best ensure safety of life and property. So again, part of what happens here is you've got unity of command to deal with the probabilities. This is, you're also always attempting to minimize the functional differentiation given the environment. But a lot of what happens is there's this big emphasis again on sort of monitoring the environment and sizing up and giving situational reports such that you're always getting the right person who's best able to manage the coupling, and also the sizing up is then communicated down. So in essence, people have shared mental models of what situation is that they're facing, and they understand, many of them, even without being told, can then understand what the right sort of ordering of things is to do. This is how they're getting their experience to become the higher level commanders. So for the naval air, you've got this, again, a tight coupling of activity, much as we saw in the last case. Again, you've got migration of authority to help deal with that, so that in this case, because it's not as spread out as a normal disaster, what you instead need to have is not the sizing up and then the sort of shared mental models to get it back down. What you often need is worker discretion and migration of authority down, because they can all see each other and communicate, because they're in a relatively small and confined space where it's much easier to communicate. They'll have headsets, etc. And again, there's a real ethic here of teamwork. These are people who work together all the time, not just at one disaster or another. That they really learn, it is very much like a team, that they're able to communicate easily, especially, again, as long as we keep the higher level commanders who aren't as involved in the day-to-day activity out of the way. The physical dimensions of the onboard runways, again, tends to mean there's a very low tolerance for error. And so here, part of what they have to do then is really work on frequent simulated practices. They actually practice how to deal with emergencies, etc., so that they keep, in essence, up to date, and even keeping those types of things more automatic to avoid any type of negative consequence.